Welcome everybody. This is the second of two events talking about getting ready to teach Pearson International IGCSE Physics, which is a bit of a mouthful. As you can see on the screen, my name is Pauline Anderson, and I thought it might be an idea to let you know just a little bit about me. My name is Pauline Anderson. I have been working with Pearson since 1988. First of all, I started as an examiner and I continued as an examiner until eventually I became a team leader. And after that, I started working on the exams directly as a reviser, then as a principal examiner. Then I became chief examiner. And I did that for about 7 or 8 years. And then I thought, I got a bit tired. I got a bit tired of thinking up new ideas. So I stepped down on that. And then Pearson said, oh, that's nice. You can now work as a trainer. And this is what I've been doing for the last few years. So I am going to hopefully try and get through all of these events, all of these aims, objectives. I'm trying to make sure that you have know how to plan the course and what resources we give you. More importantly, planning the course depends on your understanding of the assessment and how it works, and then you can prepare your students. So I'm going to be looking at the assessment objectives, the exam papers, the mark schemes, and quite a lot on the support. Okay, so have any of you already started teaching this course? Right. So is this a brand new course to you? Could you pop some answers into chat? All right. So I have one from Mr. Khan who says that he's been teaching it for 2 years. Is there anybody else who's been teaching it? Or are you totally new? Right. Just teaching it since, yeah. So maybe this is more of a top up for a number of you. So what's the most important thing you hope to get out of this course? Okay, so if some of us is returning back, are you hoping to get a sort of a refresh? Are you hoping to get some information about how we mark, how we do the papers, or the support material? Yes, student-centered classes and interesting content. Wow, that's good. Right, I hope I'm going to be able to focus on students' common mistakes. Yeah, I will be touching on some of that. At least I can touch on them, the generalized mistakes that you can do something, not the mistakes that people make with the content is often very variable from school to school. And okay, prep. How to learn. Thank you, that's really helpful. I'll try and make sure I address some of those comments as I go through. I will be giving you a short break at about 10:30 my time, so in about an hour and a half, because otherwise 3 hours of listening to me is a long day. Okay, so Pearson is a very established exam board. Some of the details actually surprised me. The fact that we have 10 million scripts marked every year, to me was astonishing. And we do operate in 70 countries worldwide. I'm not sure if I've been to that many countries worldwide, but I actually have been to quite a few. They are, I mean, they are obviously a very well respected examination board as well. So I'm going to start because we want to look at GCSE physics. So I'm going to have a look at what is in GCSE physics. There is, in fact, on the website, a mapping document which shows you the differences between AQA and Cambridge. However, it's on the modular one because the modular course is our new course. But the content is the same. So let's have a look. GCSE Physics from Pearson has 2 exam papers. Both of the exam papers will look very similar in that they will have some multiple choice, they will have some structured questions, they will have some data questions, and they will have some at least one extended response question. By extended response, I mean something that's going to be worth 4, 5, or 6 marks. We're not allowed to go above 6 marks in writing questions. 6 marks for only 1 point. So I'll talk about that in more detail. When we have a look at the exam paper, we will actually see that the exam paper is well structured in the sense that we have lots of white space. The questions are clearly separated from the answer space, and we give you the number of marks. There's no guessing. Is this worth 2 marks? Is this worth 4 marks? The number of marks is there, and we never ever suddenly decide in the marking, oh, we should have given this 3, we'll give these 3. We don't do that. The content that we cover in each paper, I will come on to, but basically the answer is that we assess all of the content in the linear specification. We assess all of the content in both the topics in both papers. There's a slight difference in that the second paper assesses content which is not in double award science. Okay, so we have 8 topics. We're split them out. You do not have to test or teach in those topics. You can make your own route through if you choose. You don't have to do topic 1 followed by topic 2 followed by topic 3. If you want to start year 10 and start with electricity, which is topic 2, nothing to stop you. If that fits your school better, then that's a good idea. The astrophysics is a topic that the kids love, but it actually is a topic 8, and some centres I know sadly leave it till the end and don't have enough time to do it justice, which is a pity because the kids like it. Every time we do an exam paper, we are assessing. We don't assess the textbook. I don't read the textbook. When I'm writing an exam question, I do not look at the question paper and the textbook. It's not for me. All I look at is the specification, and I look at these assessment objectives. And they are briefly known as AO1, 2, and 3. AO1 is basically recall, AO2 is application, and AO3 is analysis and evaluation, which includes practical work, right? And the percentage breakdown for each of these skills is the same on each paper. AO1 is 40%, AO2 is 40%, AO3 is 20%. That has major implications on your teaching, and if your end of topic tests, your class tests, your end of term tests, if you only test recall, like what is the definition of a volt, or what is meant by momentum, you are not actually doing your students justice, because 20% is analysis and 40% is evaluation. So you're only giving them if you like, you're only giving them preparation on 40% of the exam, which is not good. Right, excuse me a moment, I've had a bit of a cough. Right, in our specification, we have a lot of appendices. Some of these are for the exam officer because they tell you about how to enter the, what code to put in for the exam, etc. But for you, we have got command words, the taxonomy. We've given a full list of words. Now, GCSE physics and biology and chemistry, IAL physics, IAL chemistry, IAL biology, all use exactly the same command words. So our meanings of these words are the same, and hence it's important that we actually use them properly. So describe, explain, evaluate. In physics, we have for 30% minimum of math skills on every exam paper, right? And up to 40. We can't go above 40. So it's usually about 33, 34%. And that could be not often ratios and percentages, I'll give them but sometimes it's geometry. Sometimes it's graph work, sometimes it's substitution, rearrangement in an equation. We do often require means. I'll have a look at this, what the skills are later on. The practical skills are mostly tested, some of them are tested in A03, things like what are the control variables, what's the independent variables. But some of them mostly are tested, like the core practical is tested as A01 because it's recall. They're meant to know it, and hence they're meant to be able to do it. So if you don't understand, you don't teach any practical, again, you are not doing your students a service, you're doing them a disservice because you're not teaching for 20% of the exam, which is, a fifth of the exam is a lot to not teach. Now, you will have some students who will say, oh, I don't really want to do A-level physics, so why am I doing it now? What's the point of physics? And for these students in particular, I will actually point out that we are also teaching scientific thinking, how to think logically. A logical reasoning. We're talking about how to handle data, how to communicate. So these transferable skills are ones which they can take into any other subject and into real life. So I've been talking about the specification. Where can you find it? You find it on our webpage. This is the specification you're looking for. It was first taught in September 2017, and the first assessment is 2019, and there's been a revision, very minor revision since then. You also will find that we have a large quantity of, I apologize, I didn't mean to go back to that one. We have a large quantity of course materials over here, right? The specification and sample assessment, excuse me, is still very appropriate. Look at the amount of exam assessment material we've got, 156 separate documents. And we've also got over 50 teaching and learning materials. If you ever have a query about your physics, or for that matter, biology or chemistry, the person to contact here is Tim Lawrence. He's got his email there as Teaching Science. He may not know the answer, but he will know who to ask to get the right answer. And we have to do that as well. We've got a number of these training sessions which you can download as well. Right, now I want to change it. And it doesn't want to go. Well, okay, let's have a look. So we're going to have a look at the linear structure. We have two qualifications. They are both the same model. They both have the same content. It's how they're assessed, which is different. We don't have a higher tier and a lower tier. You enter all your students into one exam. So the beginning of that exam is targeted at grades 1, 2, 3. And at the end of the exam, it is mostly targeted at grades 7, 8, and 9. But there will be accessible questions all the way through. So the beginning of the very last question will have maybe 1 or 2 marks, which are accessible for weaker students. Right? The grade, or both papers, you can get grades 1 to 9, 9 being the highest mark. Right? We can choose. I'm just trying to get rid of my little scribble here. I didn't realize it stayed on the screen. We have got a linear or modular. Right? There is no practical exam. I know Cambridge have an exam where they test practical skills. All our practical skills are tested inside the exam paper, the same 2 exam papers. Why are you not moving? Okay. Paper 1, paper 2, they're written as a set of papers. So if they're written by one person. So the person writing them, the chief examiner or the principal examiner, will write a paper 1 and paper 2. And the reason we have two of them is that we also have a 1 PR and a 2 PR, so that they are time zoned, so that different parts of the world will get slightly different exam papers, but they're written as a pair of papers. So if something comes up in paper 1, it will only be lightly touched, if at all, in paper 2. The problem with me saying that is that paper 2 has got what we have, additional content in bold, and there's additional content in every single topic. So if you say, oh, well, they've assessed topic 1 and topic 3, we will still be possibly testing topic 1 and topic 3 because we've got more content which we can assess. We've got to look at these. I will look at some of these question types later on. Multiple choice, how many we can have, what our short answers are, long answers, data-based, and some of our planning. Okay. With a linear, we take both papers at the same time. The modular is different. They can take them at different times. But in linear, if you are doing GCSE physics, you take paper 1 and paper 2 in June, or you take them in November. If you do a resit, you've got to resit both at the same time. You can't resit one, right? There is an advantage in that we actually calculate your grade on the raw marks. We don't use the universal mark scale, right? So we just calculate the grades on the raw marks. And the grades that we receive are the ones at the end of the exam. We can't carry them over. You can't do paper 1 in June and paper 2 in November, which you can in modular. Okay, so let's have a look at these 2 papers. The paper codes are given as this, right? You'll notice that we have 4PH1/1P. I wonder if I can use, no, I'm trying to use the spotlight tool, and it's not, I'm going to give up. I think it's easier if I just use this. I will use okay, so when you have a look here on the screen, this is the paper code. This paper 1, is actually also used for the double award science. Single award science, which is 1/3 biology, 1/3 chemistry, 1/3 physics, and gives you 1 GCSE, has a separate paper. But the double award science share paper 1 with chemistry, paper 1 with biology, and paper 1 with physics. And they don't do paper 2. So the paper 2, right, I'm a bit sloppy with these. So paper 2 is almost 40% of the exam. And paper 1 is just over 60% of the total exam. Okay, we have got on paper 1 all of these 8 topics, but we don't have anything which in bold. We don't have something with a P reference. So if you're looking at a chemistry and look at the biology, they will have bold and B for biology and C for chemistry, right? Those content in bold is examined in here, but it's not the only thing that's examined in there, because that would unbalance the papers if we had everything only tested stuff in bold on that paper 2. It would really unbalance the papers. We can use a calculator, right? And actually Pearson have actually produced some nice a nice document which you can download from the website, which is helpful on how to use calculators. It might seem an ordinary skill. Right, okay, right. I'm looking at that on there. I do think you get a okay, I'm reading what this thing about the modular and the training and whether or not they're going to have a certificate. I honestly don't know. When I do face-to-face training, normally the event you actually download it a few days later. But recently I went to Bangladesh and they actually, Pearson Bangladesh provided the certificates. I believe you should get an e-certificate sent to you within a few days, or at least a link to get that certificate. Right, let's go back to what I was doing here. I do agree with you. It is actually important for your own, if you like, career development, to make sure that you have these certificates that you can show in a future employer, or even for that matter, parents. Okay. So let's paper 1, paper 2. Let's have a look. They're both assessed. They're both available in June and November. They both have the same sort of multiple choice, short answer calculations, extended open response. You can use a calculator. The questions can come from any topic area on both of them. They both, it would be very odd if we didn't assess each of those topic areas every exam. And that doesn't necessarily mean in paper 1, but it means in the whole paper. It probably does mean in paper 1 because of the double award, because they have the same requirement. The major difference is that there is additional content in paper 2 and the marks are different. Paper 1 has 111 marks, paper 2 has 70 marks, and that's actually a total of 180, is the same number of marks as we have for the modular. Okay. So this is the one that you might want to have as a printout. You will have got the presentation, so you will be able to see this in some detail. So this one tells you, as a summary, tells you how long each paper is. Paper 1 is 2 hours because it's 110 marks. So it's 1 mark per minute plus 10 minutes reading time. Right? So this one is 70 marks. So I think that one is 1 hour 15. So you've got, again, 70 minutes plus a few minutes extra reading time. You've got the content assessed, the full specification for paper 2, and only the non-bold. All topic areas, same question sounds, same depth. Really important to realize this. Paper 2 is not harder. It is more. It's not harder. So the same depth of question we can get from grade 1 to grade 9 on both exam papers. They're both designed to do the same. So don't just assume that if somebody if somebody only wants to do double award for whatever reason, they can still get a grade 9. The exam is no easier. Paper 1 is not easier than paper 2. Okay, use your calculators, obviously, and November and June. While I'm saying that, while I remember it, if your students have a calculator that gives them their answer in fractions, please realize we will never give a mark, the evaluation mark, for something left in fractions. We will only ever give an evaluation mark for something which is in as a decimal. I probably would remember to say that a bit later, but maybe not. So in paper 2, this is a section from the obviously from the electromagnetism section. In paper 1, we can test this one, we can test this one, and this one. In paper 2, we can test the whole lot. So the ones in bold with a P, those 3 comments, just construction, the magnetic field patterns around a straight wire, etc., and the fact there's a force on a charged particle when it moves in a magnetic field. All of those can only be tested on paper 2. All the rest of them are tested everywhere. Yeah, everywhere, not just paper 1, not just paper 2. Okay. When we look at the, excuse me, I do apologize. When we look at this, the exam paper is structured. So the beginning of the exam paper is relatively easy, and the end of the exam paper is relatively hard. There will be something there at the beginning or a little way into each question, which is accessible to students who are actually working at levels 1 or grades 1, 2, and 3. So if you have a weaker student, please encourage them to keep going. Okay. So inside each question, it gets harder. We tend to start with recall at the beginning because this helps to actually set the scene for the students this question is about. So it might be about waves. So we ask them a question, which is a very simple question about waves. We might and then move on to something harder and more difficult later on. So we're looking at application and evaluation. We feel that we can assess the full range of abilities in this way, but it also enables us to test those 3 AO1, AO2, AO3 across the whole page, right? Students should be aware, especially high ability students who are going to get a grade 7, 8 or 9. And please don't just think of your high ability students as people who are going to get grade 9. Grade 7 is a really good standard, right? So these are students who are high ability. They may not want to do physics further on, but they're still intelligent students who can do well. But when they look at the paper and they see question 1, they go, oh, and sometimes they overthink it. They think it's going to be asking for more detail. So generally 1 mark, 1 minute, and the beginning of the paper is easy, right? Okay, so if you've got a student who is working at a high grade, then they can actually scoot through questions 1, 2, and 3 maybe fairly quickly, which leaves them time to show their ability on the harder later questions. Right, any specific queries about that at the moment? And if not, we'll go on to looking at specific content breakdown. Answer came there, none. I can't see who's writing, if anybody is writing. I'll give you a moment. Okay, let's have a look at my content then. So, 8 topics. In all of our 8 topics, they are almost exactly the same as in Modular, but in Modular we have split them into 2 chunks, and we've split the topic on solids, liquids, and gases into 2 sections and put one in each exam paper. But here, all of the content is taught and all of the content is tested in both exams. So our specification starts with the units we expect them to be able to do. And that's the same for all of them. In topic 1, which is forces and motion, the first section of it is probably things like distance, time, velocity, time graphs, and so on. A lot of this we've done, you probably did with students in maybe year 8, maybe year 9. So what you need to do is maybe just do revision on this and possibly do it in a practical way. Practicals should be easy to do. We're looking at movement, we're looking at extension of springs, Hooke's law. We're also possibly looking at falling objects. We've got principle of moments. Again, it's not a difficult practical to do. Momentum conservation is, again, not difficult to do in some ways. Stopping distances. Try and integrate your practicals as much as you can if you're doing this, because a number of students I've spoken to sometimes get put off by the start of physics because they think, oh, I've done all these again. So what are we going to test? We're going to test anything. We're not going to focus on any one thing. So this time it might be Hooke's law. Next time it might be moments. It could be graph work. There's quite a lot that we can focus. So lots of sums, right? Lots of calculations, because there's lots of formulae. There's lots of graph work, lots of practical work. The higher mark questions tend to include momentum, and they also include what we call multi-stage calculations, where the answer to part A becomes the data for part B. And if you make a mistake in part A, we have to carry it through and do the work as well. Our second topic is electricity. Again, we're going to test all of the electricity. Now, it came up yesterday, and I'll mention it now. We've got units that we expect them to do. When they write an equation like V equals IR, we will quite happily allow them to write V equals IR, because V is a standard abbreviation for volts, I is a standard abbreviation for current, and R is a standard abbreviation for resistance. What we won't accept is V equals A over ohm, or amps over ohms. So we won't accept an equation in the units. Right? That's worth mentioning to your students. The other thing to mention is as well, try not to make them dependent on these triangle equations. They work when you've got a V equals IR or F equals MA. They work for those simple equations. But once you start using more complex equations, you've not already taught the students the skills they need to rearrange, and they will therefore probably do better rearranging it. Okay, we expect them to read and draw circuit diagrams, and we obviously don't want them to confuse electrostatics and magnets, which they do. Again, yesterday talking to the modular group, which ones of these do we want them to be able to do? And the answer is virtually everything in this column, right? We are not fussy. We hardly ever use this one. That one is rarely used. We won't make a big deal of putting a blob at the junction, but we certainly expect them to know what a switch is, a cell is, a battery, a power supply, an AC power supply, a transformer, an ammeter, a voltmeter, a fixed resistor, a variable resistor. Fixed resistor as a square or a rectangle, not as a zigzag. We probably won't need the heater. We will need the thermistor, the LDR, and the diode, and the LED. The lamp one is needed as well. Probably not that one, probably not that one, probably not that one, probably not that one, or that one, or that one. And this one is really important, because if they draw a resistor by just literally drawing a box around their circuit wire, they've drawn a fuse, and they could lose a mark for it. Okay, does that help? I hope that helps. Yeah, I wish I found these annotation things yesterday. Would be good. Problem is, I can't. I have to click everything to get rid of them. Yay. Okay. So they're in Appendix 8, a list. I think most students are quite used to doing this. When you're trying to do the practical work with electricity, I think it's FET that has quite some nice little simulations you can do. They've expanded theirs a lot recently, and they're quite useful. Right, waves. Now this is one that's gone into paper 2 in modular, but it's in both papers here. There are some differences to them in a number of things. Because we put in astrophysics, we needed the Doppler effect. And actually it's quite nice. I live very close to a racetrack. The Doppler effect I can hear if I go into my garden, I can hear it between this. There is something about the oscilloscope use and doing practicals and so on. Oscilloscopes are not always easy to find, not easy for your technicians to maintain and so on. In the extra documents I sent out this morning, one page has got virtual oscilloscopes on and a couple of other links, and the other one is a simple exercise I made as a potential starter activity or a little homework activity that you can use for AO1. Let's have a look at topic energy resources. Right. Again, we will test all of the spec. I don't know why they put Sankey diagrams in bold or on conduction, convection, radiation in bold. We are getting increasingly fussy about this. The energy stores are 8 of them, right? And there are only 4 transfers. When we do a question, there was one this summer in, I think it was paper 2P, which was set with a camper van and an energy, and it had solar panels on the roof. If you knew about energy stores, if you followed the Institute of Physics guidance on how to teach energy, it was actually a very easy question, and there were 3 marks, and there were 5 possible answers, 5 possible ways in which they could have got those marks. If you go to the older method of describing, yes, you could still get those 3 marks, but you had to have virtually everything. It is genuinely easy. And if you teach energy as a means of, it's like money, you know, just the way you can transfer money from your bank account to somebody else's bank account, and you can talk about transfers in the same way. And the stores, it can go in my store, it can go in your store, it can go in Amazon store, it can, and so on. I think students tend, especially if you teach it earlier on, teach it in year 7 or year 8, it certainly becomes an easy way of talking about energy. Please, please, please look at this word, right? The word heat is not a noun, it's a verb. We can heat some water, right? It is not, try not to use the word heat as a noun. Talk about thermal energy. Even if we are aware of the fact that thermal energy at this point is actually an abbreviation for internal energy. So all of this comes in here. All of the energy resources comes in here. Advantages and disadvantages of renewable against non-renewable. It's quite important that when you teach that section, that you realize we've rarely, if ever, include the cost. You could say that we're being quite theoretical, and the cost is actually important. If you're talking about cost, you might talk about running costs, but certainly not build cost. Okay. And as I said, that our Institute of Physics energy stores and transfers model is far more useful than the older models. From when I started teaching in sometime in the 1970s, the ideas of how we teach energy has changed considerably. Right, this is excuse me. This is the topic that has been split into 2 for modular science. There's a lot of calculations in this again, 40%, up to 40% calculations. So we've got calculations here, and we've got obviously pressure, and we've got density calculations. We have got gas laws. A lot of this, these are not, but a lot of this is actually dependent on knowing what Kelvin is. Your students are never, ever, ever going to get full marks on a gas law calculation if they don't use Kelvin. The other thing that examiners will say and often want us to do is to emphasize the fact that this is physics. It's not chemistry. As a team leader and as a principal examiner, I used to get so many examiners commenting on the fact that they didn't like the chemistry terms coming up in the physics. So things like collisions, when we're talking about random motion causes pressure, right? And we talk about the collisions with the side of with other particles, or collisions with the wall. The term successful collisions, which comes from chemistry, is not appropriate, right? And it just niggles. You sort of niggle. You don't want an examiner who's niggly and upset. You just want somebody who's going to mark it. So try to keep successful collisions in chemistry, right? Electromagnetism and magnetism. There are 3 sections, and I know quite often when you're planning a course, you want to do, oh, we'll do the electricity section, we'll do the wave section, and so on. This is one where I really feel we should teach separately and have this section. Well, this is actually probably a revision, because you've probably done this in year 7 or year 8. But teaching electromagnets followed by electromagnetic induction is almost guaranteed to make them confused. So I would teach electromagnetism maybe at the beginning of year 11, and then I would leave induction till a lot later. Okay, there aren't quite as many calculations, but there's an awful lot of concepts. All right. And yes, if you want to talk about right hand and left hand rules, we don't mind. Just warn your exam officer, whoever's monitoring the exam, that students might be doing this in midair, thinking about which way round they should be doing. Okay. Right, so let's look at the next bit of the content. I've got 2 screens for this. 2 slides. Chemistry, I've just had a go at them, successful collisions, but they teach atomic structure, they teach isotopes, they teach nuclear symbols, and they do it fairly early on, because how do you talk about equations unless you know about the symbols? How do you know about the structure? And you know, you can't do a lot of chemistry, you can't do bonding in chemistry unless you know about atomic structure. So it's a good idea to talk to them, see what they're doing. Don't do the radioactivity until they've done atomic structure. Okay. The alpha, beta, and gamma radiation, again, it's not easy to do. If you are in a school and you haven't got you haven't got any sources, I know they're difficult because of the rules and regulations that you have to store them, and you also maybe have import rules, etc. It's a difficult topic. There are simulations that you can do this. So on the document that I sent earlier this morning that you can download with the oscilloscopes, there is a link to a company in the UK which is called Focus e-Learning, and they do a large quantity of practical simulations, which are designed to go from year 7 to year 11, or sorry, to year 13, in biology, in chemistry, and physics. And they are, I always feel annoyed when I have to talk about paying for. These actually are quite reasonable. This costs £100 per year for the school, so that for every teacher and for every student can use the simulations. And the reason I mention them is that I think it's in one of their A-level sections, so just go looking for it. But they really do a fairly good simulation on radiation and penetration and so on, which allows you can put it on the screen in your room, and you can actually do it together, and it gives random errors as well. When we were testing this in this summer, we found that virtually everybody could identify a Geiger-Müller tube. Not many could spell it, and that didn't matter. We didn't mind. If you want to call it a GM tube, that's absolutely fine as well. Okay. This is an idea that still hasn't come through. We've been teaching this specification now and examining it now for 5 or 6 years. The idea about the difference between contamination and irradiation still is not one that's actually come through. We still find that one is one that's not well taught. Okay. So let's have a look at, so that was, we've got that, and we have the other section of it, fission and fusion, right? We don't tend to mark spelling down, as I've just said. Fission and fusion are ones where we are a bit more fussy. If you spell fission with one S and a clear I, it will get the mark. If you spell fusion with a U but 2 S's, it will get the mark. But if you start, we really do want to make sure that that I and that U are clearly distinguished. So if you've got somebody with very poor handwriting, please actually make sure they print this so that we can understand which one they mean. I've had to go about using chemistry terms. Here is where we tend to have biology terms, because they talk about daughter cells and daughter nuclei, because they've done cell division in biology, and you end up with the daughter cells and so on. Please don't bring in those terms in the fission and fusion. And the fusion is in there, a lot of it due to the fact that we need the idea of fusion when we come on to our next topic, our final topic, which is astrophysics. There's a lot of interesting work here. In all my years of teaching, I didn't find a student who disliked this topic. They might have said, I don't know why we're doing it, but I quite like it. I quite like it. And there's a lot of material online on this. NASA produces some wonderful material as well. The cosmology, again, is introduced. They're going to have this at A level. And the maths for this section, for the cosmology, and in fact, the maths for this section, both require that students can use standard form. Right? So much as I like saying, put this in when you can, put this in when you think is appropriate, let the students teach it to themselves almost, please make sure that they've done standard form in the maths department, because otherwise they're going to have major problems. So, right, we have a handout, and I'll show it to you a bit later, about the standard form. Right, so I believe that now you are going to get an exam paper with all of the formulae tacked onto the end of the paper, much like they do at A level. And I never could understand why they didn't do it in GCSE. Possibly because at the time the regulators for home GCSE said you've got to learn some things. You've got to learn things, not do them, not rely on them. To my mind, the skill is knowing which equation, not necessarily remembering it. Yes, there are some that they're going to remember very easily because they're using it time and time again. But there are so many here that, for example, mention speed, right? And then you've got a velocity there, and you've got another velocity, and you've got speed down here, and so on. And it's knowing which of these equations, because when you come to the SUVAT equations as well, knowing which equations to use, which is the right one to use, is the skill, not simply recall. So, okay. it's up to the end of almost an hour. Just going to have a little tiny amount of thinking time, right? And the opportunity for you to actually share some of this. Which topic is most challenging? Nobody's actually nobody's writing anything as far as I'm aware. I mean, I always found, as I said, which is why I'm keen on the electromagnetism and the induction being taught differently. The most challenging thing is that section. It's very, yeah, magnetism. Yeah, the whole electricity and circuits, electromagnetism. Yeah, it is challenging. Physics, we're talking about abstract ideas in an abstract manner. And it's really hard. Yes, I always used to make a motor. I think they enjoyed making a motor. I'm not sure if they learnt a lot doing it that way, but they certainly remember the lessons and they remember enjoying it. These specific examples and techniques, I would always say, are things like one, making it active, making it as fun as possible. The other one, which I will share with you, is maybe more accessible for some topics, and that is using whiteboards a lot of the time. The problem is, in any class, I don't know how large your classes are. When I worked in Zambia, my class size was 50. When I worked in an all girls grammar school in the UK, my class size was 20. But there's no matter how big your class is, there's always going to be the students who doesn't want to be involved and wants to sit back. And the difficulty is making sure that they are engaged and making sure that they are taking part in the lesson. And I'm very much of the view that you, as a student, as a teacher, should involve your students in different groups at different times, so that when somebody comes into a room, I might say, okay, you're red, you're blue, you're green, you're yellow, you're red, you're blue, you're green, you're yellow. So when I want to do practical work, the reds have to work together, the greens have to work together, and so on. And I can mix and match my groups so that I am constantly keeping, if you like, keeping the students on their toes, making sure that they are not complacent and they're not working in a group with their friend who is going to do the work for them. Right? We'll talk about some specific ideas and techniques later. Right, now we're going to look at these assessment objectives. These are close to my heart. This is what I write when I write an exam paper. I have to write 40% knowledge and understanding, 40% of application, 20% of experimental skills, analysis, evaluation of data, and so on. Okay? So what are they in things? That one, the previous slide, is something that you might want to share with parents. Because parents, when they say, oh, I helped him with his physics revision, they are actually only doing recall. And they're not testing all of this. It's a big demand for a parent to test application, understanding, and analysis, especially if they're not don't have any scientific background. Right. Oh, I've just noticed thermal energy and thermal physics. Yes, it is a hard topic. Again, it's not. Some of it's counterintuitive. This topic, right? This slide I think almost should be, if you have a class, if your students are writing in exercise books, this should almost be stuck at the beginning as a stamp. This is it. I'm going to remind you, only 40% is recall. And show it to the parents. This is a bit more detail of what do we mean by recall? We mean facts, we mean definitions, we mean concepts. It can include describe the structure of a transformer. It's recall. It's something you can find, pick up a textbook. Can you find the answer to that question in the textbook? If it's the answers, if you can, it's probably AO1. AO2 is usually applying this to an unfamiliar context, right? So in which case, we probably are going to be looking at interpreting data or talking about our thermal physics. Again, we might be looking at convection, but we apply it to the seaside, where you get breezes coming onto the land, differential heating of land and sea. We set a question a few years ago where we talked about the fact that you can have the chimney effect, pulling air through a building connected by a long tunnel underneath the ground where they would have been cooler. It's a way of it's a traditional way of cooling a building. So we're looking at application, right? We're looking at, do we know this? Where is physics applied? Right? Where is physics applied? From the camper van with the solar cells. All of these are unfamiliar contexts. The experimental skills, if you don't teach the skills, not just by doing the practical, sometimes by doing the simulations, then you're actually going to make, you're losing up to 20% of the marks, right? Our questions are designed to cover all of this, right? Parents often help their students by, or their sons and daughters by asking recall. So maybe in class we should concentrate on the AO2, the application. Maybe when we're doing revision, we should concentrate on data analysis, right? If the students don't know what they're going to be assessed on, they're not going to do well. Right, we're going to have a look at AO1. They are, some students like them. Some students like them because they can memorize. I got through my history O-level at the time by pure memory. I didn't particularly enjoy the history I was doing. I had a really dull teacher, and I ended up taking my exercise book with one of those multicolored pens where you clip the color. So I wrote 2 paragraphs in pink, followed by a paragraph in blue, followed by a paragraph in orange. So as she gave us notes, so when I came to revise, I revised, oh, there's a pink section, there's an orange section. And it was basically recall. I didn't understand it. I didn't like it. I passed. I got the equivalent of about a grade 6, maybe a 7, but I didn't do well. So students quite like doing recall. It feels comfortable. I have revised it. I know this content. And then they wonder why they don't do particularly well in the exam. And they don't do particularly well in the exam because they've actually only learned 40% of what we're examining. So those are some of the things that they can do. Okay. Now, how do you help them with this? All right. How on earth are you going to actually be able to help them? This is the sort of question that they're going to get. All right. We've got state, give, give, give. we might get describe. We often don't get explain, right? We get typical questions like this. How can you help them to learn this? When your students come into the room, as they're coming into the room, on your screen, you could have 2, 3, maximum of 5 short questions. If they have a white, what we call a mini whiteboard, which might be something about this size, about the size of an A4 maximum, and they write their answers on this. When they're ready, they turn the mini whiteboard up so their answers are facing down, and they hold it in midair. You can glance around the room, you can see who's ready to answer the questions, and then they can turn them up and you can a quick glance and test their things. This sort of a mini test, it can be done at the beginning of a lesson. It takes almost no time, and if you want to use it as revision, or you want to use it as next week, I'm going to be teaching, for example, nuclear physics. Do they know what's an isotope, etc.? So you can use it to help reinforce the typical questions. So a typical AO2 question is going to have unfamiliar contacts. It's going to have data tests. It's going to have data somewhere. Again, is it worthwhile saying to your students, take in a highlight pen, highlight the data? Or is it a better idea to actually say, when write down the equation, write down the data for that equation so you can see what to put in? We're going to always have calculations, but we're also going to have words like suggest, evaluate, explain. Now, particularly with explain, we're going to require first A, then B, then C, then D. We're going to need a causal thing, right? AO2 is not going to feel familiar. It's going to require some deeper thinking, some multi-stage thinking, and things like, students often go, oh, but you didn't teach us about this. Okay, but they should be able to apply what they know. Right? When you see the word suggest, it often means you're going to have to pull it from more than one topic. Not always, but sometimes means that it can mean that. Right, these are typical AO2 questions. Now, you can use the same mini whiteboard technique to give them a calculation of velocity. Calculate the velocity of a car which travels 120 miles in 3 hours. They should be able to do that. If they can't do it, it gives them gives you food for thought about why are they in that. And these, again, some of these simple equations can be done on mini whiteboards. How do we teach it? We can teach it by modeling. We teach it by making sure that we have given a number of practice items. Now, in maths, when they do equations, they will do days of those equations. We haven't that luxury in physics because we've got a lot of content. But if you talk to your maths department certainly about the mathematics, the calculations, then you can introduce it in the same way that they do, and they might be able to, you can actually give them some questions they can sling in to their days of practice, and you can say, okay, here's a physics question. So talk to other people, okay? What it does to our students is, and if they're getting grumpy about it, you're trying to make them think like a scientist, right? We're not just recalling facts, we're trying to apply them. We're trying to think and explain and get on. So these are questions which have appeared in recent papers. Okay, Suggest why a lawnmower has 2 switches instead of 1 switch. Right. We've also got questions such as this. Sometimes I did say describe is often for A or 1. Describe how the force applied on ball A compares with the force applied on ball B during the collision. Right. So we're actually looking at Newton's laws there. This one is an explain. Quite often explain questions, if they're worth 2 or 3 marks, it's worthwhile thinking of them as state and explain. We're only allowed to give 1 command, but we are allowed to help them with what we call scaffolding. Right? So the information here on this question, it becomes magnetized when placed in the magnetic field. Explain why it experiences a force, and you may add to the diagram. Well, the obvious answer to add to the diagram is to say, put a little n here and an s there, and then then a student should then be able to see, oh, look, I've got 2 opposite poles, and hence I've got attraction, and attraction is a force. So we can train our students to do well with these questions, right? And we certainly have to when it's AO3. When it's AO3, we are looking at making judgments, making evaluations, and so on. The Pearson lab book is extremely good with this. And we can have a look. I will show it to you later and show some of the other things Pearson have. But this is the questions. When we've got evaluate, discuss, justify, improvements, limitations, there's an awful lot. It's not just doing the practical. And I don't want the practical to become like a cooking exercise. It's more about the criticality. Which instrument should I use? Why am I using a milliammeter rather than an ammeter? What would I be best? Is a trundle wheel better than a meter rule for measuring this distance? This is the sort of critical thinking that I want to encourage. It's going to do them in good stead. These are the sort of things that come into AO3. Explain whether experimental data supports the hypothesis. Interpretation of a Sankey diagram. Analyze the velocity time graph to determine acceleration and distance. So these are all skills based rather than just recall again. Oh, sorry, I missed a slide. Right, okay, AO3 questions. How you can measure height accurately, right? In this case, explain with reference to the principle of conservation area why the student suggestion would not work. So that's also targeting a recall of what is principle of conservation of energy. This one is something that you could actually possibly see in junior area. If you train your students in year 7 and year 8 to be able to do this, when they come to year 9, 10, and 11, they should be fine on it. Control isn't as useful I'm not saying it isn't as useful. It's not as common in physics. It's very important in biology, but in physics, it's almost, it's not as common, right? So our words that we use are actually ones which they almost signal which question we're going to do, right? So if we have a short answer question, it's going to be things like describe, suggest, explain. We do not need your students to write in sentences. We do not need them to write the question out again. They can use bullet points. They can use numbered points. We don't mind. There are no marks for spelling, punctuation, or grammar. We're not testing that. It would be ridiculous, really. I mean, this is for physics. Why am I testing English? Right? If they can read it in English and they can answer it in simple English, fine. I am not going to penalise spelling mistakes. I am not going to penalise them if they don't put full stops and capital letters. Right? That might be a school policy in your school, but it's not required in the exam. Right? Not required at all. When we're looking about planning, I'll talk about it again in a bit more detail, methodology and variables. It's often quite easy to do. The maths-based questions, please get them to make sure that their equations are equals. The equals stays in the same place, and they don't do something like 8 divided by 2 equals 4 divided by 3 equals, because it makes a nonsense of it. And it will only impact when if they get the answer wrong, to be honest. But okay. Teach the styles early, model how to do it, especially the ones which are not recall. Right? So how many multiple choice? You can get a maximum of 10 on paper 1 and a maximum of 5 on paper 2. We can only have 15% of the marks are pure recall. So that pure recall is things like, what is the unit for pressure? That's pure recall. We can only do 15% of the marks. All right. So we must be careful about making sure that when we are when we look at them, they actually interpret the data. When you do multiple choice questions, it's a good idea to teach them to say, right, which is the obviously wrong answer? Right? Which is the one, or pick out the 2, right? And then, so they think they've got a choice between 1 to 4 marks. And in actual fact, when they look at it critically, they're probably choosing between A or D and not A, B, C, D, right? For you, they are very helpful because they can actually help you identify which misconceptions they can do. Now, we call them multiple choice questions, but in actual fact, they're often closed response. Closed means we give them a number of answers and they've got to identify the answer. So, which is a white dwarf. Since you don't see the rest of the question, that's irrelevant at the moment. But here, again, probably based on the HR diagram, and they have to identify the different sections from that. You could almost, even without the HR diagram, you could, if you knew the HR diagram, you know that the black hole doesn't appear on it, the nebula doesn't appear on it, the supernova doesn't appear on it. So you could almost say, well, it's probably not the neutron star. So you could almost, can you see what I mean? If you're teaching this as a skill, they can eliminate things because these other ones that put a line through don't actually appear on the HR diagram. Sometimes you've got a calculation, right, which is this one. Again, easy peasy questions, but they do identify misconceptions. When we have short questions, we're often using describe, explain, suggest, and we don't often use them for AO3. I can't say it long. Do not write in sentences. Now, we talk about how to read a question. when we talk about reading a question, it's not just the words, it's actually also the information. Okay. In this question here, we have got two marks. What is that telling us? Right? And it's also we're told control rods and the moderator. So they've given you a structure. If you write only about the control rods, you are not going to get 2 marks. They've separated it out. Sometimes they do it 1, 2, but they've given you a structure, right? Usually it is 2 marks, 1 mark, every 1 mark gets 2 lines. In this case, they've given 3. They expect people to wonder. When it says a give or a state, again, it's going to be 1 mark, right? And there's got 1 line, right? So our students should be able to read the question, read what the examiner has said. If sometimes they've given them question, they've given them space. So that's actually quite important to have a look at that. Let's look at some of the longer questions. Okay, these are points based, they're not level based. 1 mark for every valid point. No need for full sentences. Focus on making your language accurate scientifically. Bullet points are fine. Number of lines should be twice the mark allocation. Phonetic spelling is allowed unless it could be confused with another. So if they write gravitational, as they've done there, that's fine. If they write refraction, it's too close to both reflection and refraction, and we wouldn't give a mark for that one because we think they're fudging it and we're not certain what they're trying to do. So looking at these as longer questions, a red giant star becomes a white dwarf star. Discuss the differences between. Now, my first thing would be, okay, and I would do a red giant and I'd do a white dwarf. Now, immediately that makes you think about the differences. So you need to think about what differences can I talk about, and you might talk about the temperature. You might, etc. There's all these different things that you might want to do. You might want to talk about the size. Right? It's obvious. You might want to talk about hydrogen or helium. Right? So you can almost give yourself a structure. And if something is like this, as an examiner, I would be very happy to see this sort of thing, even if the student does it at the side like this, and you can see that. Again, 2 pieces of evidence. We've got the information, it's 2 pieces of evidence. So I would do 1 and 2. And I'd first of all state what my evidence is and state what the second piece of evidence is. And I've also got what the Big Bang Theory is. So I also might want to write what the Big Bang Theory and write that down. And immediately I have got, of my 6 marks, I've got 1, 2, and 3. So this is what I mean about trying to teach the students how to answer the questions. It's not simply doing the question, it's not simply giving them, it's telling them how to structure their answers so that they are effective in the exam paper. And they've got, oh yes, I need to do that. You will find some of your very able students know this and so on. There are some who want to throw everything they know about that topic to the examiner. Right, I'm just going to talk about AO3. AO3 is something that is a little different between biology, chemistry, and physics. Not in the sense that what we've got to test, but it's how you approach teaching practical skills. Biology, to some extent chemistry, they have something like, I don't know what it's called, sometimes I know that, CORMS. They have a structure, a framework. Your biology, chemistry teachers may use it. It's not always helpful. I contacted the chief examiner of linear and the chair of modular, both physicists, both colleagues of mine that I've known for a while, and asked them about their use of CORMS, and both of them were very adamant that they didn't want it. And they thought it was inappropriate for physics, not helpful. This is bit from the chair. He said, physics investigations are quite different to biology and chemistry. So this one is not a structure that's helpful. Physics tends to have fewer variables to control. It's concerned with the range of the data and the total quantity of the data. This was evident in one of the questions of paper 1P. And not many students picked up about the fact that there were only 4 bits of data, and you really should be looking at probably 7 to 8. The data wasn't across the full range and so on. We are concerned about analyzing. We're concerned about being critical. So if you're not teaching CORMS, this is what I suggest you actually think about, right? That we put together a question list. Now, your question list could be slightly different, but in my mind is when I've given them, I'm thinking about a practical. Which equation am I going to be using? What quantity should I measure? What am I going to use to measure these quantities? How am I going to do it? How often? How long? How am I going to organize the data? Should my data be in a table? Should I put my data in a graph? How am I going to improve accuracy? So if this was voltage and time, you could see that you would need a voltmeter, stopwatch. Voltmeters are connected in parallel. Stopwatch is started when the switch is closed, how often, every 20 seconds, etc. Right, so you can use this. So let's have a look at applying this to a couple of questions. Right, so this one is a specific heat capacity of concrete. Now, they're required to know the specific heat capacity of a metal block, but this is concrete. But the principles are the same. So this immediately becomes an application. It's still AO3 because we're planning. But if we think about which equation applies, we can think about, oh, look, which equation applies, right? And we also have these rearrangements. Which quantities should be measured? Mass and time. With what? We've also got them, right? How often or how long? We've put them in here, right? Every 10, we've got this change. How are we going to organize the data? How often or how long also is keep taking the temperature after the heater switched off? How are we going to improve accuracy? Can you see how those questions will lead them to getting those marks? Right? So I much prefer that they actually consider the questions themselves. Let's get the rubber eraser. So a second one of these, right? So this one was a couple of years, was it last year? It was either last year or the year before, fairly recently. it was a thermal heat, and they had bottles of different colors, and how could the investigator have the color of the bottle? Well, in this case, there wasn't really an equation, but there was this thing about the diagram. I haven't really mentioned the diagram. In the diagram, if they drew a heater here, and that was the heater, and they put one bottle at this point and another bottle at this point, and they did, that's D and that's D, we can actually give them, place both bottles at equal distance, so that would have been a mark, right? We could show the equal volume again in each, like that. We could have given a mark on that. They're getting the same heater output, so that could be a mark, right? Can you see the diagram would have also been helpful in this case? But this list of questions, again, how to improve accuracy is usually a mean, and repeating how best to organize the data and so on. All of these questions could be used to generate good answers in 803. I think I've got a very few on the question slides on this section, so I'm going to talk them through and then give you a short break. Right, I'm going to go back a slide. Our command words we've almost mentioned already, that they are the words which we have the beginning of word of a question. Describe, explain. They really do need to know the difference between those two. They're the ones that come up most often, most commonly misunderstood. So we've got the taxonomy at the back, in the appendix. The questions will actually span a range of demands, and some of them on our list, apologies, some of them on our list will actually mean calculate without using the word calculate. There is the word calculate, right? Comment on could be, right, a synthesis of a number. Look, draw, reach, again, could be determine, right? There must be quantitative marks in there. Estimate, evaluate, identify sometimes requires it. Justify often requires you to do. You've got plotting, which can plotting. Okay. Linear in any graph on IGCSE physics and IGCSE and IAL, a sensible scale is never a scale in 3s or 7s or any other odd numbers. You can use 2s and 5s. They will condone 8s. They don't like them in 8s, but they will condone 8s. But please never ever, even if it means you've a square or two and you haven't used up the whole paper. So you can, again, these are all the taxonomy. These are the words that you need to use. Isn't it odd when I move to the next slide? Some words tend to be with low demand, like state, and some words which are evaluate, discuss, are increasing demand. All of this sample assessment material are available on the website. You have this. Do feel that you can use the modular as well. It's the same group of people. The principal of the modular is somebody who was a team leader, so he's very well rehearsed in this sort of thing. There's a massive amount of material on the website, and there's a massive amount of past papers. Will you please note that some of these past papers like this a lot. What we do is we will not release those past papers until a year after the exam. So last June's is locked, last November's is locked, and June 24 is now open, right? You as a teacher can access this via your exam office, and they will give you an access, right? In the material, you've got the examiner's report. It's really quite helpful. The question papers, the mark schemes, they are really helpful for everything. Right, I'm going to give you a break. It's now almost 20 to 11 in my time. So I'm going to give you a 10-minute break, and I'll see you here back before. If you want to make comments in the chat, please do so. But I'm going to switch my audio off and top up my coffee. Okay, 10-minute break, please, everyone. Right, it is now 10:50 British Summer Time, as Gina very kindly put up. So I'm going to start by actually thinking about this discussion point. How can you introduce command words? How can you ensure that they're familiar with them? And the answer is, again, test them. Use a mini whiteboard. Maybe talk them through. There were a couple of questions this summer on transformers. I don't mean to say use this summer's work, because you may want this last summer's as a mock exam and so on. But thinking about questions in previous years, you might pick up a question on transformers, one which is a describe and one which is an explain, and structure how the answers are different. Where are you going to get that back from? You're going to get that back from Exam Wizard, which I'll talk about a bit later. So our core practicals, I'm talking about them. There are 20% in the exam. Do them if you can. It's not always possible, but certainly you should be able to demonstrate or use simulations on each of these. So the ones I've highlighted are the ones where you have got them in the paper 2 only, right? The rest of them are meant to be in paper 1. The very bottom one, it sort of sneaks in. It doesn't start with investigate. It sort of has describe how the current and how to investigate this experimentally. So we do expect people to know how to do this. It's worthwhile having a look. The fact one is pretty good. They're not too bad, and the link I gave you to Focus e-learning is worthwhile looking and seeing whether it's whether it is possible for your school. I don't know if there's any way of doing it as if you're a tutor and only selectively teaching people, but there are others. There are other companies. Khan Academy is obviously very good in many places. Physics Online is also good. We haven't got a practical assessment. Cambridge do. They have a written paper in at GCSE, and there's a practical exam in the AS level as well. So when you are looking at past papers, when you are looking at them, do not just simply stick to IGCSE, because our list of practicals is very, very similar to the list of practicals for the home GCSE. This link for the simulations is actually on the document that is in resources. It's down as, I think it's down as virtual. The title of the document is virtual oscilloscopes. But if you look down there, I've actually put the link on it. And I think I've also, if I remember rightly, I put the link for FET on there as well. So it should be on that document, and it's available on your Zoom controls, right? Any queries, I think Jira might be able to help apart from that. So these are the things we want to assess them on. We might want to assess them on problem solving, identifying variables, and so on. This is the sort of question you could get them to answer. Right. So how does a student do this? How are we going to mark the 2 marks for this? We would expect them to have columns. We would expect the columns to have headings, and the units are in the headings. We would also expect them to have it in some sort of order, whether it is right, whether it is in alphabetical order, or whether it's in order of the power. So starting with laptop at the top and television. So you can model this as an answer, right? This one definitely means that you've got to use that virtual oscilloscope. I quite like I've given you, I think, links to 4. 4 of them are different. Some of them are really good for A level. Some of them are better at this stage. And I think at least one of them, as you speak to your laptop or whatever it is you're viewing it on, it will pick up your voice, which is quite nice. And you can see the voice trace going, and you can, pardon me, you can freeze your voice train at that point. Improving accuracy. You see, our way of testing this is slightly different from the biology. Okay, now we have got from Pearson, there is a lab book. I actually quite like the lab book. I think it could be, it's quite useful, especially if you're a new teacher, especially if you're not used to controlling a class during these practicals. What it means is that everything that's in the book is accessible, and it goes through what they should think about, how to organize the method, how to organize the data, how to analyze the data, and it links to the sort of questions that we put in. If you are limited, this idea of doing a carousel approach, that means that you have a specific day of the week when you're going to do practical, and maybe it's a Tuesday, you never know. And you take one group of students and they will do practical 1, another group of students will do practical 2, and somebody else will do practical 3. The following week you swap round. So there are advantages, because that means you're only needing one of any one piece of kit. Some technicians quite liked it because they could just park all of that kit, but I tended to find that there were 1 or 2 students who didn't like the idea of doing specific practicals, and they were away for that one, right? I believe, talking to other teachers in different parts of the world, that if you do that, if you are banking your practicals, it's always on a Tuesday, that there are a number of students who don't turn up because they think the practical isn't important, and actually it is crucial, right? There's a list of all of these practical investigations at the back. I couldn't imagine trying to do all of these inside the time that you've got. However, some of them could be done at year 7 or year 8. Okay, you could, for example, have a look at this one, right? That certainly could be something that you could do lower down the school. You could investigate something like bouncing balls lower down the school. This one, we actually was in this year's exam, running up the stairs to find the power. So look at this list and think, can I integrate it? Maybe integrate it lower down the school, right? Teach practical explicitly, right? It's a skill. You wouldn't, if you were if you were teaching somebody to drive, you would teach the skills of how to reverse around a corner, how to do a 3-point turn, how to do an emergency stop. These are skills that you need, and they are the skills in driving. So we can teach our skills little and often. Even if you get an awful set of results, it can still be useful. So, okay, these 2 are available on the website. There's also one now from Modular. Please feel that you can steal from that one as well. So there's a guidance on using practical terminology, which is fairly short and is quite useful. This one, the core practical guide, is really, really important. And I came a couple of slides from it, or a couple of clips from it. So it actually now tells you what you could do to enhance the learning. Right, this one is obviously about a spring. And it's the sort of questions that as you are helping students in the room doing the practical, you can say, well, what happens if you've got a thicker wire, right? How can you measure this length, this change in length accurately, which obviously is leading through to A level, where it is again a required practical that they know Young's modulus. All right. How can you practice getting the data, looking at this? So they link in the math skills. So they also look in and take an exam. How does that skill, how does it appear on a past paper, right? So they've given you an example of the question, suggest how you can improve the data, and I've stuck in the mark scheme and the teacher's comments or the principal examiner's comments and what the sort of things is. So if you haven't downloaded this, it is actually really, really helpful. And the modular one has been updated, and it's and you can steal from it. There's no reason why you should just concentrate on that. Jira has put up here where you can get the links to this document. When I did it yesterday, I had to send it separately at the end, but this is I decided to do it early this morning. So they are those links, and you can have a look. Right, math skills. Really quite a thing. As a physicist, we are normally really confident about our ability to do maths, and we should be. I know that when I went home after my first year at university, and I was talking to some of my friends from school, and some of them said they'd gone to a different university to do maths, and they were astonished when they realized just how much maths I had done in my physics degree, and they'd done quite tiny bit more in their maths degree. And I said, well, this is just one bit of my physics, and I had so much practical and so much, and they went, how did you manage? And we don't even think of it as being difficult. We actually think of it as being an easy thing. However, what we are not necessarily very confident at is teaching it, right? And maybe we shouldn't be. Maybe we should actually be talking more to our maths department and looking at this, because they will teach a maths skill and they will practice that maths skill. What we have got is a harder thing. We have got a maths skill inside a science content, and that is a hard thing. The things we should be teaching more of is things like data analysis and interpretation. And how are we going to use a certain equation once we've done an experiment? We want our students to be confident. So talk to your maths department first. Make sure that things like I'll put down here standard form significant figures, but the thing that really stands out is the number of students who do not know how to rearrange an equation such as kinetic energy equals half mv squared. Now, it's not really a difficult equation to rearrange, but they don't know how to do it. The other one is a v squared equals u squared plus 2as. Especially when you've got, it's not just f equals ma, and they know how to do that, but it's when they've got a second term. And if they're not confident in that, so maybe that's what I'm talking to about about teaching the maths and getting the maths department to do that. If you have to use v squared equals u squared plus 2as before the maths department have taught it, you are making it harder for you, right? So put the maths where you can, as often as you can. There's rearranging equations is the biggest thing. The other one is standard form, right? Standard form, significant figures, and so on. In an exam, we sometimes have something called a power of 10 error. And this is sometimes occurs because people have, or examiners or students have not changed into SI units. So their answer comes out to be 1,000 times bigger, for example, if it's mass, or it can be odd numbers if it's time and they've left their time in minutes rather than seconds. So we have to be aware of the errors that are introduced by not changing units. We sometimes call these power of 10 errors. Standard form is one where we can see this quite often, and significant figures. Okay, how many significant figures should we work to? Are we going to take our calculator and write down an irregular a number? I've looked at this one on my screen and it's 1.4907118 Will my students be penalized if they write the whole of that down? And the answer is generally no, unless we've given them an instruction to write their answer correct to 3SF or 2DP, or write their answer in standard form. Okay, so we're not going to penalize. Yeah, so look at the question. Is the question written and all the data given in 3SF? If it's in 3SF, then the student should be working to 4SF all the way through. We take account of the fact that some students will, at the first stage, round to 4SF or round to 3SF and then work to 4SF, round it up. And so that when we look at the answer line, we give what we think is the right answer. And then we also have a range, which allows for students to do things like using G as 9.8 instead of 10, and using and rounding at different points. So we will give that as a range. Generally work to one more SF than given in the data. If it's a show that, you have to. If you do a calculation and you don't show, it says, suppose it's close to 500 and you don't have an answer, which is 485, no, 485, then you haven't shown it, right? So you need one extra, okay? You can introduce the skills by building them in. You can use quick starters. Exit tickets are a bit like what I was talking about with mini whiteboards, but you give them a calculation or you give them a query, a simple calculation, and they can only leave the room when they've got, as they go out, they've got to give you the answer. I'm not sure how useful exit tickets are. I have heard that they are useful in different parts of the world. I had some teachers in Hong Kong who said they use them regularly. But if your students have got public transport to get back to, or they've got another lesson to get to, you could be holding them up. Give them data handling tasks to do. And again, build up the confidence. It's all about not just testing recall. In biology, they have this list. They do not need to do or some of the math skills, which is just as useful because their percentage is 10% maths. Chemistry has 20% maths. Physics has 30 to 40. So you can see why the only little things that we don't have to do is sampling, and we don't have to know the terms mode and median. But everything else on that list we are meant to do. These are the sort of calculations. I talked about kinetic energy. This is the one they can't do. They can't rearrange it. And I don't know why they can't rearrange it, either because they're using, they have that half and they haven't changed it to mass times speed squared over 2, or they haven't changed it to 0.5 times mass times speed squared. As soon as they get the squared, they go, oh, I don't know what to do here. And they're not good at doing cube roots and square roots. Notice what we do. We give a structure. So this question tells them about the voltage, tells them about the current, and it's making them think about the formula, right? So there's 1 mark to make them think about the formula, and then a mark to do, and then the calculation marks. Sometimes they're in multiple choice. Sometimes we're not going to give them that hint, but that might be earlier in the paper and that might be harder later in the paper. Okay, so on the Pearson website, there is this really nice guide again. It's pretty big. I think it's something like 168 pages. And it's extremely nice. I agreed. It's something that I was really pleased that we'd produced this document. It was very, very helpful. However, I can't see any 15, 16-year-old wanting to sit down and read 168 pages. So we did recognize this. So what we've now done is, again, on the website, you can see that's in the documents. It's also on the Modular site as well. So we have actually produced let's have a look. 1, 2, 3, 4, 5. 5 is probably not useful in physics. 6, 7, 8 documents. And then there's another one, again, the core guide. So these are the documents. Now, these are much shorter. This one is a huge document, but if you look at the size of these, they are PDFs, and they're easy to download, but they're quite short. And the reason they're quite short is that we have designed them for our students. So I picked out this particular one, and this is the one which I feel is really good in physics, because allows them, it shows them how to use the calculator. So it's not just the fact that they don't know what standard form is. Some of them do, but they don't know how to use the calculator, and they certainly don't know how to use it when you've got this sort of number, right? So 10 to the minus 15, right? So they're showing how to enter it. Start with 1, right? Start you don't hit you don't hit the multiply, and they've shown it in red. You should show them how to hit the EE key and so on. So they've actually shown them how to use the calculator, and I think it's so useful. I would have some of these in posters on my room when I'm doing this. When I'm doing astrophysics and I need tiny numbers. When I'm doing I don't know, maybe again it could be it could be atomic and astro. Maybe I'm looking at doing orbits and I want big numbers, and I would have this on the wall, or I make a handout from this. I think this one is about 4 pages, so it's not too big. But the other ones are useful. How to round decimals. You would think it was a skill that they'd have been taught in year 9, maybe. Gradient one is really helpful as well. I'm talking about the decimals. And again, we're trying to target the problems we've seen. The sampling one is one that comes up in biology. The rounding comes up virtually everywhere. The tables, charts, and graphs ones comes up everywhere in science. So this is what we've been trying to target to the students. Right? I hope you find them quite helpful. Right. Is there anybody want to share anything else, or have I talked you into submission? Right, so we've looked at the structure, we've looked at the skills, we've looked at the assessment things. So now let's have a look at planning that course. Okay, what we have is got an editable scheme of work. Now, there's an editable scheme of work for different models. So there's one for a 1-year course, a 2-year course, a modular, and a linear. They're all on the website. They are in Word, which means they are editable. They're not just a PDF. So you can access them, again, from the qualifications website, but you can customize them. I was talking to some of the teachers recently in Bangladesh, and talking about how can they most of the teachers there are Muslim, and obviously they are having to go to school during Ramadan, and it's a difficult time for them, not simply because it's a religious occurrence, but also because they are fasting. It's a hot country, and the students still have to go to school. You're not going to get the best work out of 15-year-olds who haven't been able to eat for hours. I mean, most 15-year-olds, I think, are basically a walking stomach on legs. You could feed them all day, every day, and they'd eat continuously. So you can take this scheme of work and you can take a section that there's either, you can plan that to be revision, or you can plan that to be so some group work activities, so that you're not doing heavy conceptual work with them during a time when they're going to find it physically demanding, right? Again, if you have bank holidays or fixed holidays in your country, you might want to think, I've got 2 weeks, I can't squeeze that in. No, you may not be able to squeeze the whole of the electromagnetism in, the whole topic, but you could do the magnets, or you could do electromagnets in that 2-week slot and leave the 3 weeks. So there's a lot of information there that you can actually move around to fit your country, to fit. The Pearson resources have got the active learn, and they're great. But I will say again, the textbook is for your students. They support your teaching by giving you some worksheets and guest assessments, but they are really, in a sense, for your students. If it's appropriate for you to pick it up from another, if you are moving from a school that's been doing Cambridge and you're moving to this one, you don't necessarily need to change your textbook. Physics is physics. So one of the resources we've got is a mapping document. I think you'll find it on the modular course. So it will take you from what the topic was in Cambridge to what the topic is in Pearson, right? So that is all available on there. The textbooks, as I say, are the active learning section is really helpful and useful, but it's not necessary. It's not a constant requirement. So where is the planner, right? So you've got these on here, right? So there's a comparison between the UK and the international. There's a comparison between Pearson, Cambridge, Oxford AQA and AQA. The mapping document, there's a mapping guide for single and double. So all of these are available on the website, which enables you to think about, if I'm moving from this, what do I need? They've got specific points to link to lesson activities. There's tasks for teachers, tasks for students. There's an amazing amount. You could sit and read it for a week. What does it look like? So one of the schemes of work is looking at energy transfers. And again, I would really concentrate and try and use the two things I said. Use the Institute of Physics ideas. So it is thermal transfer. It is try and use the word heat as a verb and not as a noun, right? It's thermal energy, okay? Or it has been particles heated over time. There are sometimes, I think it was, I think there's some in the Australian curriculum, and there's a section on using concept cartoons. And and this is what we mean by a storyboard. So somebody over here saying that bottle of milk in the fridge is going to get colder the longer we leave it in, which is a common misconception. And this sort of misconceptions. So you can actually target misconceptions using storyboards. Some of the demonstrations they've got are useful and straightforward. I mean, I'm sat on a chair at the moment, which I have to reach down and put my hand right underneath to get to any metal. But if you were in the classroom and you've got a wooden bench in front of you and a metal frame on the chair, most people will actually say the metal is colder, and they're confusing the temperature with conduction. Whose name is it? I don't know the guy's name. Do you know his channel? There's a channel on YouTube called Veritasium. Again, it's an Australian scientist, a physicist, and he's targeted quite a few of the misconceptions. He's very good. Some of his work on conduction of electricity is excellent, but certainly not to be shared with your students, but it's really, really good. So the lesson plan gives you activities. They give you the page references for the student book, the lab book. Teaching Hub is a new scheme with Pearson. It is a paid-for scheme, and it's got a lot more material. You basically it, it does everything that you need to. Right, there's an enormous amount of material on that. This at the end is giving you the sort of skills that we're looking at, that we're trying to teach problem solving, we're trying to teach analysis and reasoning and so on. So this is the typical thing that we're going to get from the scheme of work. There is one for every single topic, and it gives you how many weeks, how many lessons, whether it should be year 1, year 2. It's all there. It's an amazing amount of material. Okay, I'm going to make an apology again, because when I vetted this, I didn't spot that these sections were from the biology, right, which is a mistake of mine. I should have done something a bit more than this. But you can see that they link in quite nicely. The biology's there, the chemistry's there, and so on. It's the same thing. Sorry, apologies for that. Maybe I should have pulled it. I don't know. Okay. It's not clicking. This should, as I click, this should give me to, oh, maybe it is clicking a bit. Yeah. It should be an interactive thing. I've got to click in the middle of the screen. Right. We've mentioned facts. The Institute of Physics has got quite a lot of material on the website. Some of it is a little old-fashioned, and quite a bit of it is targeted at A level, right? But there is material on there. PhET is very useful. It's targeted, it's an American thing. So again, it doesn't necessarily mesh quite easily, but they've taken on that on board that I've mentioned. If I have an opportunity to, right. So when you're planning your, I might have a look and see if I can get the Focus e-learning up and let you have a look at that as well. I think I might have time. If you are devising your work, be careful about thinking about your school, thinking about your country, thinking about where, what's going on in the lives of students around you, where the exams are, and plan accordingly. These are ideas. They are not necessarily going to give you going to match exactly your work. So feel free to edit it as well. All right, let's have a look at my, right, as I just said, it's a guide, it's not a prescription, right? So these are the things that you have there. We have built in time to talk about topic tests. So let's go on to marking. Right, how do we mark in Pearson? And the answer is we try to be as positive as we can in our marking. So let's have a look at a typical mark scheme. First of all, to note in the mark scheme is this bit. When we have this, what we have got, it shows every semicolon shows a mark, right? When we have a simple alternative, right, concrete absorbs, weakens, radiation, because there's 3 possible marks here, right? Gamma is highly penetrating, gamma is harmful to humans, concrete absorbs, or we don't necessarily, I don't know where this is from, weakens. It's a simple alternative. If it was an alternative with 3 or 4 possibilities in the middle, we might put it in brackets. And I'll show you the sort of brackets, what we call curly brackets. We will have over here what we are to ignore. So we want the word penetrating, we don't want high range. We will allow a given harmful effect and mutate cells causes cancer. Be careful, because saying it is harmful is fine. If this were UV mutating cells is not good enough, causes cancer is not good enough unless it's skin cancer, because we know it can't be. UV cannot penetrate through the layers of the skin. We've got allows, so ignore. So if they said gamma is highly penetrating, or gamma has a high range and is highly penetrating, I'm not going to knock a mark off for the range. I'm just going to ignore it. It's almost as though I'm putting my thumb over it and ignoring it. If I talk about mutating, so if I have the allow, I'm looking at alternative ideas. Sometimes we write them down as an idea, because there's so many ways in which the student can say it. So we're not going to be terribly fussy about the ways in which they can say it. Okay. There's another example. We have got down here again the semicolons, meaning there are two lines. Notice 1, 2, 3, maybe it should have been 4 lines. I don't know if I chopped it. Allow reasonable alternative to split. Fission is a breaking of a nucleus into 2 parts. Fusion or allow alternative for combining, including fusing. Reject. If they talk about atoms, so if they say fission is a splitting of an atom, it will lose the mark, right? So we have so occasionally rejects. It is the nuclei that we're concerned about in this, and reading the mark scheme yourself will tell you how the principal examiner is thinking about the physics and how they're going to test it in the future. So on any mark scheme, the left-hand side is a question number. The middle is written by the principal examiner. After the exam has been sat, the team leaders sit with the principal examiner and they actually expand that mark scheme on what we expect our students to answer. If we've got keywords, we will sometimes embolden or underline them. The right-hand column is our guidance column, and it classifies things like accept, allow, condone. Condone means we don't like it at all, but it's been standard practice, and at some point in the future, we reserve the right to say, no, we're not accepting that particular answer. It's verging on being wrong. All right, we don't like this. So if we ignore, imagine putting your thumb over the top and not reading that part of it. Do not allow and reject. If that comment is there, the mark cannot be awarded. So if we see a word that's been underlined, must be included. We can't not accept it. Bold lines have got to have, bold words have got to have a very close synonym, right? If we've got smooth brackets, ordinary brackets like this, then the words inside are optional. We don't have to see them. The meaning or the context has got to be there, but we don't need to see that. Frequently, they are referring back to the start of the question. However, if we have these brackets, right, can you see what I mean by a curly bracket? Anything inside the curly brackets, there will be 2 or 3 or 4 or more different things. You have to have one of those words or phrases included, right? Now, this is obviously something when students are take things down from the website and they don't understand the mark scheme and they think they should have got the mark because they had something there or they didn't have this. This is something you really need to teach them. And maybe it's something that parents sometimes need to teach, to be taught. Our idea is should be marked positively. If the scientific idea is clear, then that gets a mark, right? If we use the key vocabulary, we're not marking spelling, we're not marking punctuation, we're not marking grammar. I say this again and again and again, right? So no long essays. Right, practice the terminology, practice clear explanations, practice having well-structured responses, practice having bullet points, and so on. Right, so excuse me if you get a view of my screen. I'm going to end the show at this point and then take the time. I'm noticing it's about 25 to 12 my time, British summer time, and I have got basically some corporate material to have a look at. So I'm going to show you the you can see how messy. Right, let's get rid of that. I'm going to show you, this is the document that you should have seen earlier. Right, so this is the one that I think I'll get yeah. Okay, let's have a look at this one. Okay, so this is one of the virtual oscilloscopes that you should be able to see. And as I'm talking, if I speak loudly, you can see the max, it alters. And you can alter the gain, you can alter the number of things. So it's quite a nice little, that's quite a nice little toy. It's not necessarily useful for doing, shows how it works, but it doesn't necessarily useful things like this. So you can do a sine wave and you can change the hertz. So there is, let's put it on 400. And you can see that the size of the sine wave changes and you can talk about the gain and so on. So you can do quite a bit with that one. Let's have a look at this next one. Sorry, that one takes a while. I know that one takes a while to load. So the third one is something which again is quite useful. There's a little video embodied. I think it's one which is possibly better for your sixth form, right? But it is quite a nice little one. Let's go back and see if the other one has actually loaded yet. Right. Right, so you've got this one and it's got a power button. And you can alter the, oh, sorry, the signal generator wasn't on. And you can also have a look at this one. So it's quite a nice little simulation on that physics zone as well. And the fourth one of these is in the middle of this. Again, some ideas here which are useful for maybe your sixth form. So you've got a virtual oscilloscope again. Okay, I hope that was useful. I don't know if this one was let me in. let's see. This is the link I've given you for Focus on Science, Focus e-learning. They have got quite a lot of information in here. If I pull up, they were very kind enough to give me a link as my demo, and this is the sort of information that is here. I use these quite a lot. I think I'm just trying to remember where the radioactivity experiments are. I don't think it's in manic. No, maybe. Might be in. Yeah. Right. So there's this one is showing you half-life of protactinium. It shows the setup, and then it gives you a simulation. And you can take the source away so that you can do, for example, you can do a count rate or a total count, and you can look at the time and click your way through the time, plot the points. I think you have to do it. It's an A-level one, so they make them do the plot the points as you go along. If you put the source in, plot the points, and so on. So there are some. There's a fair amount of it in here. Let's go back and let's have a look at some of the physics experiments. And some of them are simple simulations. That's quite a nice practical. Again, allowing you to change it to the different materials between, and allowing you to change the thicknesses of the lead and so on. It's a nice resource, and I think that if you remember looking at the main screen here, all of these resources are available. So if you've got a chemistry, all the required chemistry practicals are there as well. You get 14 days of a trial run. So I don't get any fee. They don't pay me. They don't pay me. They don't pay me for the virtual oscilloscope as well. And those of you who haven't met it before, effect. Again, this one is free. They are doing better at doing some of this work, any changes and forms, masses and springs. So they've brought in some what I would call more accessible and useful physics. I quite like some of the work they've done on the refraction. Again, doing the optics when you're in a very hot country and you've got to put the blinds down is not a good idea. So there is information on that as well. Okay, so what I'm going to do is, I hope, I'm going to minimize that again. Minimize that again. And then carry on playing from the current slide. All right. So what can we do? to support you? The answer is there's a lot of information on the website. It's just pick it up and choose it and select it. So on the website, you've got the specification. Now, I've now discovered the difference because there's another guy called Jonathan Wong who's also been brought into the team. He's more to do with the support material, but sorry, I've missed him. Tim is more to do with the exams and contacting the examiners. So Tim Lawrence or Jonathan Wong both are contactable at Teaching Science if you've got queries about the Pearson information. We've mentioned it before. You've got the specification. You've got past papers, some of which are locked. You have a lot of information on the forms and teaching material. There's masses of information, which is nice and is free. Now I'm going to talk to something. I wish I was back in a school. Results Plus is, I think we're the only exam board that has this. You as a teacher can ask your exam officer for access. What it enables you to do is to identify what went right and what went wrong with all of your students. So they give you an opportunity to do an analysis of the of all of your student exams. You can have a mock analysis. So if you print a past paper for the students to do, you can look at managing the marks and then analyze that against the exam that was done. You can do this for each teacher in your school or each teacher in your department. You can do it for each class. You can also, if the student is transferring to your school from another Edexcel school or any other Pearson school, you can get their results as well. So it's quite helpful. Oshan, yes, you will get a recording. You will have the ability to get a recording, but I think it takes a day or two to come through. So the Results Plus is, I can't get it because I'm no longer in a school, but it does enable you to pinpoint what went right, what went wrong with your cohort of students as a whole. So when we take the paper, we scan it. They scan 10,000 exam papers in an hour in Rotherham. The students the examiners mark it all online. We actually only ever mark in an image of the student's paper. And then it comes on to the Results Plus and the performance reports come through at that point. When your students have got the exam, when they've done the exam and they've got the results, we have got something called access to scripts. Again, this is via your exam officer. It enables you to view your candidates' marked scripts online. So the exam Results Plus give you the data so that you can look at the data for the class. This allows you to have a look at the students' work online and see where exactly what they did wrong. So they came out thinking, oh yeah, I killed question such and such. I got all of the marks in the calculations. And when you look at them, they might have only got one or two and you think, why? So you can actually look at them. So you literally get a PDF of your students' work. Okay. I think it's, again, it's very, very powerful tool. I know that last week in Bangladesh, some teachers showed them to me and said, well, can you explain why this? And I mean, when it was A level, I couldn't explain it. I could explain. One thing they did say was this thing about the scales. And they'd got a scale going up in 15s. And I said, well, there's a mark lost immediately. And they went, oh, but it looks nice. And I said, yeah, it's not allowed because it's very difficult to check the plotting, and so on. So this access to scripts is really important. See your exam officer or the Pearson representative in your company to make sure you get access in future. As I'm sure you're all aware, that's our student textbook. It is an active learn textbook, which means it's got lots of things embedded in the textbook that you can use it on your screen as well. The lab book, I don't know why the lab book isn't on there. It's very helpful. I found the lab book very helpful as well. This is Jonathan, who's our new person helping. He is, I did want to clarify what he was doing and what Tim was doing. I thought, oh, Tim moved on. No. They're both working together at this point. So contact either of them. Jonathan is particularly important in the support services and the documents that are going up on the website and so on. And they cover a whole of international science. If they don't know, if Jonathan or Tim don't know the answer, they will know who to ask. And if I get asked a question, I am given a very, very tight time scale to make sure that I get the answer back. And so on. So I have almost come to the end. Are there any further questions about this at all? And if you have, put them into the chat. And answer came there virtually none. Huh. Okay, so if there are no further questions, then a few minutes early, I'm going to say thank you for your attention. Thank you for your queries. And I hope I've given you some information that enables you to go away and plan your work. And keep remembering, the textbook is for you. No, the textbook is for the students. Yes. Right. And keep